Okay, can you hear me, Matt?
Yes, we can.
Very good. All right, well, good morning, everyone. As Matt said, my name's Mike Wolf. I'm the engineering section manager in our drinking water division. Been doing drinking water engineering and specifically surface water plants for quite a few years. And my group includes a number of surface water engineers and an analyst that cover all of the surface water plants in the state, as well as the groundwater under direct influence. So basically all the water plants that are subject to the surface water treatment rules throughout the state we handle. So to build on previous sessions, I believe Davis Rozier had presented on filtration and did some filtration problems. We have a short presentation on direct filtration, which is just a slight nuance. And then we're also going to be talking about membrane filtration. So we actually have 3 different presentations on filtration, but it's one of the most important things we do. So before we jump into it, I was also just going to mention it's a little difficult to do these virtual classes for learning versus being in a classroom. But please do not be shy or hesitate to put questions in the chat. We are here to learn. And no doubt we have a wide range. Some people that are maybe just getting into water treatment, and this might be a first introduction and they're going for the first certifications. And then we may have some other more senior people that are here for continuing education or for a higher level exam. So don't be shy, put the questions in there. We want to, I guarantee I will misspeak on something throughout here. So we want to clarify and make sure everyone understands. So with that, I'm going to turn off my camera here so we can focus on the slides, and then we'll get going. So all right. Okay, so what is direct filtration? Direct filtration involves the same processes as a conventional water treatment plant, except there's no settling or sedimentation step or clarifier step prior to the water being applied to the filters. So the name is pretty self-explanatory. So what the process looks like is there may be some pre-treatment, perhaps feeding oxidant out at your intake, perhaps, or possibly some powdered activated carbon. Then you have a typical coagulation, flocculation step, just like you would in conventional treatment. And then that water would go directly onto the filters without any settling. And then post-treatment as needed. Usually that would be in the form of disinfection. So here's an actual direct filtration plant schematic. So you can see you've got your water getting pumped coming in, and you have 2 static mixers right here. That would be like your rapid mix, where you're introducing your coagulant. Then it goes into a series of flocculators. So you're building up those floc particles, conditioning them for filtering. And then from there, notice there's no settling step. It goes right on to the filters. And then, like a conventional plant, there's also disinfection that's required. So usually there's some type of a reservoir where you get detention time with your chlorine disinfected water. So that's what it looks like. Okay, so a couple requirements for, you might be wondering why direct filtration, and a few of the requirements if you're to have a direct filtration plant. The key thing is you have to have a high quality and stable source water. So low turbidity water, consistent water quality, also low total organic carbon. And the reason for that low total organic carbon is a lot of the organic removal occurs in the settling step. And so if you don't have that settling step, you're perhaps a bit more limited on the amount of organics removal you can get. So if you're a high TOC source water, direct filtration might not be a good application. And in terms of low turbidity waters, that's a relative term, right? So what we mean by that, I think 10 state standards says consistently below 10, or on average, I think it's consistently below 10 NTU coming in your source water. So even on a bad day, your water comes in less than 10. And we're kind of blessed in the Great Lakes with good source water, and it's not uncommon to get that low of turbidity water. And then it also needs to be stable. So storm events, seasonal impacts can cause interruptions in source water quality. So we would need to have a source that is consistently good quality. And then I guess one other requirement, if a new direct filtration plant was proposed today, we would most likely require that it have filter to waste capability. And that's just because you're putting, so much emphasis on the filter barrier. If you were to get difficult water to treat, having the ability to waste it if the filtering is not being effective would be important. And just a reminder, what filter to waste is it basically takes your filtered water, and through valving and piping, you can close a valve so no water is going into your finished water reservoir, and open another valve so it just filters to waste. And you can do that until your turbidity settles down and you're getting acceptable turbidities, and then you can switch it back so it goes to the system. All right, coagulation requirements. So in a direct filtration process, there's a subtle difference between what you're doing in a direct filtration plant and a conventional plant with the coagulation flocculation process. You're trying to create, in a conventional plant, you're trying to create a floc that is readily settlable, so a big dense floc. Whereas in direct filtration, your goal is to get a filterable floc. So it's a little bit different, and that's something that can be fine-tuned with your jar testing process. And then I guess one key concept to remember, and I believe this was talked about in the coagulation presentation earlier, but if you remember how media filtration works, it's through a process of particle attachment. It's not straining. So if you remember that slide where a floc particle is much smaller than the pore space between the media grains. So with direct filtration, it's very critical to get that coagulation process correct. So you destabilize the particles so they have the ability to attach to the filter media. So that's one of the key things. Okay, so what are some of the pros and cons of direct filtration? Direct filtration plants typically are lower capital cost, just because you don't have to construct that enormous settling step. And as a result, there's also a smaller footprint. I would argue that most of the time a direct filtration plant will have lower operating costs. You're not going to have as many residuals that you would have to dewater and dispose of, less maintenance, and little simpler to operate because you don't have that settling step in there. But Some of the cons to it is you have very little detention time and you're missing that whole settling step. So if you do unfortunately get upset in raw water quality, that's like on your filters very quickly, and there's little time to react. So that's one thing where direct filtration plant operators need to be on their toes. They really need to be watching to see if there's any changes in that source water. And then one other minor con is, as I'll show on the next slide, there's higher disinfection requirements. And here's what I mean on that. So conventional versus direct filtration plant, you're required to get, we'll focus on the Giardia here because that governs 2.5 log removal is what you're credited for on a conventional plant. But in a direct filtration plant, you're only credited with 2 log Giardia removal. And the reason is you have an additional barrier here with conventional. You have that settling step. So you're physically removing particulates in that step, which you're not doing here. So we only award 2, which means to get to that 3 log of crypto and Giardia requirement. In a conventional plant, you only need to get a 1/2 log of disinfection. That's your CT. Whereas direct filtration, you need a full log. So it's not a big deal. It just means perhaps a little bit more detention time or a little higher chlorine residual to achieve that. So this presentation was short and sweet. Most of the filtration concepts we covered previously, and we just wanted to talk about the differences with direct filtration. So with that, I am going to attempt to get to my other presentation here. 1 second. I'm going to stop sharing for a moment and pull up the other presentation.